Today, the objective is to take Maya and do a bit more work. The Maya A1 model is essentially a first pass. Think of it as our first attempt at trying to document or understand the opportunity in the way. So then from version A1 we move to version A1 V1.2, right? And so we added a slightly better model for traffic. We zoom in. We added a slightly better model for traffic that gave us a sense essentially of what kind of ad spend or marketing spend Maya would be looking at, right? And then right towards the end, we added a data table to get a sense of what is the range of profitability for Maya with respect to both conversion rates and click-through rates on their side, right? Today what we're going to do is we're going to jump to model, where is it? We're going to jump to V5. And this is what we have to build. So we haven't built it as yet. This is the game plan for today. Today we're going to make the ad spend model a bit more sophisticated. So we'll add this part. We've already done this to some extent, but we'll do this a little later. We'll calculate a measure that's called customer acquisition cost, or CAC. And customer acquisition cost is a really important component concept, not just for offline and online businesses, but also for businesses that need to think in terms of how do we scale, how do we grow our top line. Generally with top lines you have two choices. One choice is that you focus on adding new customers. So a lot of emphasis is spent on making sure that you get new traffic, you get more people, you create more exposure, and more customers come and see you try your product out and ultimately buy it. But there's a second model, and that model is what we call the retained customer model. And that model says, I have a pool of retained customers. How do I convert them? And if I do a good enough job of converting them, what part of my order pool, what part of my customer base comes from repeat customers. And the big benefit of figuring out how to work with retained customers is that you get to reduce your CAC, your customer acquisition cost, quite dramatically. The third part you're going to focus on, where do the numbers for resources come from? So in Maya's case, I think from a structure point of view, what we want to do is we want to think in terms of, if you're processing X number of orders per day, what type of staff, what kind of people, what type of resources do you need to execute on that, right? And then you get to your order processing cost. Then you also estimate, the revenue that we capture, the revenue that we get. Remember, Maya is an online store. Do we get all of it, or are there small pieces that get shaved off on account of frictional costs, which could be processing costs, which could be payment costs, which could be shipping costs. We factor that in. Then they're setting it up in UAE. They have a major presence in Pakistan, and they don't have any presence in UAE right now. So how do we add that? What kind of overheads come from? So all of this will get added at the top. And the objective of adding all of this to the top is to end up with a reasonably realistic model and see, how does that model grow or get to the next stage, right? So that's one part. I think the second part is that even on the P&L side, there are a couple of pieces that we have to fix, and we have to get them to a stage where, so when you look at models, you have to think in terms of two mindsets. Our objective is to take a simple, basic, crude model and get to an answer quickly. And we get to this answer quickly. Why? Because we want to get to a stage where we have thought through the thinking behind the model and we're comfortable with it. So that's one part, right? But the second part, and that's an equally important part, is how strongly do we believe in the model? How strongly do we believe in the recommendations made by the model, right? And that belief is a function of how strongly we believe in the inputs, the various inputs we've plugged in. So all of this work that you've done on the side, how real is this? How close to facts is this? Is this coming from actual data and realistic assumptions, or is it coming from, numbers that we just picked up from the air? So that's one part of the exercise, right? I think the second part of the exercise is, what does the model tell us? So both in terms of recommendations, in terms of next steps and action items, what are the insights we receive and get from the model? Where do these insights come from? In our case, in the methodology that we're following in this course, and for Maya's case, what we're doing is we're using data tables on the side to get a sense of where do the different ranges, where do the different assumptions lead to. And in Maya's case, I think the specific question we're trying to answer is scale. We're trying to get a sense of how would Maya scale their operations. So when it tries to scale that operation, where does that sweet spot lie, where Maya can grow, Maya can survive without significant injection of outside capital. Remember, it's a founder's own firm. Their primary objective, it's a lifestyle business to a large extent. Their primary objective is to pay their bills, grow their business, keep their customers happy and satisfied, and yet have time to spend with their 2 kids. Right? That's the key part. So they don't want a lifestyle that's driven by priorities set by external stakeholders, primarily investors and shareholders. So they say, we are the primary shareholders. We decide what time of the year we work, what time of the year we take off. We decide how much time we spend at home in the warehouse with our kids. We decide, what defines the priorities in our life. And that's the primary question. And that question, they've decided they don't want external capital. So for them, the question of growth is a function of, okay, how do these numbers work and where do they head to? And for us, that question gets answered by data table. So the reason why we're putting in so much effort in the model is that we need a dynamic model. We need a model that has moving parts, that has components that can move around, so that we can do this, so that you can do the tables that you see in front of you. If you have a static model, then this is not possible. So the rationale, the reason, the logic behind the effort of putting so much time in making sure that you have a extendable design is that you have a good, solid, extendable design. If you have moving parts that can be tested, that can be analyzed, that can be tweaked for different ranges, that gives you a sense of what the future holds. The only challenge with data tables right now is that you max can get to work with maybe 2 variables at a time. So 2 drivers. So now the question, and this is the question I proposed earlier, is you have a certain number of orders that are coming in. How many resources do you need to process those orders? And to do that calculation, we have to do certain metrics and assessment. Let me see if I have space. Where do I have space? I have space here. Okay. So here, let me just add a couple of rows. And as I add these rows, what we're trying to do is we make space for adding everything that you saw earlier. So first question is, how many orders, how many people do we need? How many resources do we need to process our orders? So first, how do you answer that question? Where do you start? You start by assuming what's the processing capacity per resource, processing capacity per person, and let's assume that this number is constant, but might improve as we get more efficient, as we add more technology, as we learn more about how to get better at what we do, right? So let's say that one resource takes about 10 minutes to process an order, and think about what are the steps, what's the sequence involved in shipping an order. So I get an order, I assign it to the pool, and then the person who's available in the pool prints it out, he has, with the order, he has a pick list. So that pick list says, we need to pick, shoes of this type, size 4. We need to get, 6 to 12 month onesies, and they're there in that component. We need to also go pick a pair of socks to go with the shoes, and we need a bag of diapers, and this is where they are. So the pick list basically says, here's the item of the order, this is where you'll find in the warehouse, this shelf, this cabinet, this level, and then they bring it to the packing table where somebody compares the pick list, the order, and the items in the basket, and then they pack it, they wrap it individually, so to make sure that if something's breakable or something that is a little delicate doesn't break, and then they put it in the appropriate size bag. Then they print a shipping label, then they close the bag, or maybe they do a final cross check for quality purposes. They throw in a few sampler pamphlets and brochures, special offers, deals, coupons in it. They close the bag, they slap the shipping label on top of it, and they call the shipper or add the order to their ship list, right? So there's a fair bit of stuff, and we're saying, it takes about 10 minutes for one person to process this, right? So if they take 10 minutes, that basically means they can do about 6 orders an hour, and each shift will run for about 7 hours. So you have about 42 orders in a day. Does that make sense? 6 orders an hour and 7 hours a day, so 42 orders. So how many people do we need to process these many orders? How many days are there in a month? So let's say they work 25 days, so days in a month. Let's say do processing 25 days. So as per this math, processing capacity per person per month would roughly turn out to be 42 into 25. So one person can do about 1,000 orders a month. Does that make sense? Does the logic make sense? So six orders a day, 7 hours in a day, 25 days in a month. I can do about 1,000 orders per person, right? So how many people do we need? Resources required. Resources required become this, which is 900 orders divided by processing capacity. And what we do is we round it up. So we round it up to 0. So 1 person. And we scroll this here. So now what you need to do is, because you've done this calculation, you can just extend it, and there we go. So from a shipping point of view, we're saying where Maya stands right now, as of this specific point in time, they just need 1 person for the shipping, packaging, packing, pick list, right? Now this is assuming it takes them 10 minutes to process an order, right? And they don't take any breaks in between, and they can work essentially 7 hours in a day with maybe 3 breaks in the middle. So between that, they can process about 1,000 orders a month. Now the question is, if you've done this much, right, you're saying I'm going to need 2 people in total to process and ship the orders. And at some point in time, as the volume increases, as the numbers increases, then I should be able to add more resources and more people. And the way we've done this is, if you increase, let's say Maya becomes wildly successful. We said these are the total search impressions, right? And let's do total search, total impressions. So if I do total impressions, that's going to be sum plus this and this. That's 15 million impressions. And I'm going to link my click-through rate with the same. So I'm going to change the model a bit now. I'm going to take, rather than linking it to my paid impressions, I'm going to add total impressions to this mix, which means this row will become, rather than D10, it'll become D12. So I've had a big step up. There you go. And I take this forward to about, say, 4% click-through rate. So that's done. This is also fine. Let's in fact take it a little higher to 0.4. So 4% click-through rate and 0.4% conversion, right? So now you can see, that the number of resources has jumped up. And this I want to make sure is constant, doesn't move forward. So what we previously had, where we had 1s and 2s, we now have 3s and 4s. And how did this happen? What just happened is, because we took a formula, because this processing capacity comes from a calculation, 1, and your resources required comes from another calculation, which is 2, right? A combination of these gives you a dynamic model. And the reason why this dynamic model is important is, as you'll see, as we move forward, you'll find that as we add resources, you would need other things for those resources. For example, one thing is space. Where will these guys sit? And how much space do you need for them? And while, if it's let's say 3 people who are doing this, maybe you need a 4th person to optimize your process to actually do the packing and shipping. So you have one person who just does the pick list, goes to the warehouse, picks up the stuff that needs to be picked up and brings it out. One person who does a final QA check on it, and then a 3rd person who does shipping, packaging, and printing. So there are 3 different roles, 3 separate functions. And maybe you need that once you've hit a certain threshold of orders. Maybe you need that once you sort of figure out how to make the right process with the right background. What you want to make sure is when and if you do that, your model should change accordingly. So this is the first part. So we've added our first pool of resources are people that we use for this. Is our shipping model, right? Let's add this here. Why is that a problem here? Okay. So this becomes, let me just call this my shipping model.